In the previous video we looked at the second and first law, some notes on them, and in the notes on the third law here, we know the author of this book loves firing bullets at planes out of the sky. This poor bird is going to get hit with a shotgun, and what we're trying to show here is that the force of the bullet going this way has an opposing force going in this direction, and hopefully you've never shot a gun, but if you did, your shoulder here would have a big bruise on it the next day from the gun recoiling or going backwards into your shoulder. As the bullet comes out, the force forces the gun back this way as well. So this is Newton's third law. When we're looking at force, an ice skater pushes the side of the wall with a magnitude F, and the wall doesn't budge because the wall is secured. But the wall will push the skater with the same force F in the opposite direction. So that's why you would start moving if you pushed against the wall and you were on ice skates. And here's our first example now. A car of mass 1500 kilograms. Its engine produces a tractive force T, which is a pulling force, of magnitude, and we're dealing in newtons here, 5,000 newtons. But there's air resistance, or of magnitude 2,000 newtons. Ignoring friction, which will come into these questions, we're going to call friction mu, to find the acceleration of the car. So when we get these questions, we're going to do a block or some sort of thing to show what's going on. So we have a pulling force in this direction. So there's, when we deal with friction, we'll have like the roll will be friction or pulling along a table, but in this case there's no friction along this line here. So we just have a pulling force and we have a resistance force. The pulling force is 5,000 in that direction, and the resistance force is 2,000 in that direction. So I can say that the force, the resultant force, is equal to 5,000 newtons minus 2,000 newtons. I can leave it the n out to the end, so that's the resultant force here is going to be 3,000 newtons. Now this is where we apply a formula. So we've only had two formulas so far. We have this object of mass m, and it's getting pulled down towards the ground. So it's mg, the mass times gravity, which we showed was weight. And we also had the force was equal to ma. And we have m here of 1500. So that's where we can write force is equal to 1500 times a. So a must be equal to 2. And we write that as ms to the minus 2, or m over second squared. So that's the first example here. Now we're going to look at tension. So tension is a force exerted on objects by strings. And we're going to have these strings going off multiple objects. So we've weight going down, as we just showed though. And one of the formulas that we have, weight is equal to mg. It's pulling an object towards the center of the earth. So this is a lamp hanging from the ceiling by a string, and the string exerts an upward force on the lamp, otherwise the lamp would fall under the force of its own weight. So the only external forces on the lamp are its weight and the tension in the string. We can say that T is equal to W here, and then there will be multiple things at play, and we'll be able to calculate whatever unknown variables we have. And tension always acts along the line of the string, away from the object, always, never towards. Okay, never towards the object. So that's the end of video 3, nice and short. Get these notes into your copy, take the example down, take the solution to it down, and we'll look now at some more examples in video 4.